Hi guys, so we're going to continue with our cosine graph, but we're going to do a different transformation, which is your horizontal stretch and horizontal compression. And I first want to just remind you what this sinusoid looks like. Okay, so our sinusoid equation is f of x equals a cosine of the quantity bx plus c and then plus d. So your amplitude is that absolute value of a. We use b to help us find the period. So to find the period, I'm going to take 2 pi and divide by the absolute value of b. And then the c is going to tell us if we are going to shift left or right. And then the d is going to tell us if we're going to shift up or down. All right, so C is left or right. That is a horizontal shift. And then D is a vertical shift. But this horizontal stretch and horizontal compression deals with your period. So every time that you see a b value, something in front of that x value inside the parentheses, that's going to tell you you have a horizontal stretch or a horizontal compression. Okay, but first I want to go ahead and draw the cosine function. And I'll kind of do this throughout just so you can see the stretch and compression. But as a reminder, for the cosine function as your parent function, you have a maximum at 1 located at 0 and 2 pi, which is 6.28. You have a minimum of -1 at pi, and you have zeros at 1.57 and 4.71. Okay, so here is my cosine function that I'm going to do the transformations of. Okay, so again, knowing the maximums, the minimums, and the zeros of the cosine function and the sine function for that matter makes it a lot easier to graph. And notice we're still using those quadrantal angles. All right, so let's go ahead and get started. We've got our parent function, this y equals cosine of x. I'm going to go ahead and graph that just so we can compare it to this cosine of 2x. And you can kind of see whether it's going to be that horizontal stretch and horizontal compression. All right, so I've got my parent function. I'll just put a PF beside it for parent function. All right, let me switch to a different color. I'm going to just go red. And we're going to graph this y equals cosine of 2x. All right, so let's see here. The amplitude, well, that's the absolute value of a, so the amplitude is 1, just like in our parent function. The c, there is no shift left or right. The d, there's nothing added to it, so there's no shift up or down. But I do see that b is equal to 2. Well, that affects my period. So the period is 2 pi over absolute value of b, which is, let me put in there, 2. Absolute value of 2. Well, let's see. That is 2 pi over 2, which is pi. The period is pi. What that means is between 0 and pi, I should see that entire cosine function. So this is going to be that horizontal compression, a shrink. Horizontal compression, which is your shrink. Okay? So what that means is that my x values are going to get multiplied by 2 to give me those y values. So here, when I draw this, important to know the period. So once you take care of the period, you've already done that transformation for the b part. So I'll have a maximum here at 1 and then at 1. Again, I'm drawing it in between these red dashed lines. Halfway in between there, well, that'd be pi over 2. I'm going to have at -1. And then my zeros, well, let's see. If I have 1.57, if I take 1.57 and divide it by 2, because it is a compression, then that's going to be 0.785. So that should be right around here. And then if I have between 1.57 and 3.14, I'm going to add, let's see, I'm going to be right around 2.4-ish for my other zero. Okay? Here is the cosine function of 2x. Notice that's a horizontal compression of 2. Okay, horizontal compression of 2. All right, let's just say I wanted to do another period. Well, another period is another, what, pi? So that means between pi and 2 pi, I should see another cosine function. And there you go. That's another period. So from here to here, from 0 to pi, that is my period. So now I see 2 revelations, 2 cycles of this cosine function in this graph. That's a compression. Okay? I went from a period for my parent function from 0 to 2 pi, and now that has shrunk to a period for my new function, 0 to pi. Notice the period is shorter. That is a horizontal compression. All right, let's do another one. So let's take a look at this y equals cosine pi over 3x. So let me go ahead and, again, I will just draw that parent function just so you can see the transformation that's going to happen. Notice this parent function has a period of 2 pi. Okay, so let's talk amplitude. Let's see, there's no a value. Let me get back to red. I'll do this in red. There's no a value, so that's 1. So the amplitude is going to be of our new function 1. The b value is pi over 3, which now changes my period. So let's figure out if this is going to be a horizontal stretch or a horizontal compression. So the period is 2 pi over absolute value pi over 3. All right, well, let me go a little old school here. 2 pi divided by pi over 3 is the same as 2 pi times the reciprocal 3 over pi. Let's see, pi's canceled, that gives me 6. So my new period is 6. Okay. Technically, if my parent function is a 6.28, which is 2 pi, and now my period is 6, that's going to be a horizontal compression, because the period is smaller than 2 pi. All right, so that means between 0 and 6, I should see a cosine function. So I've got my zeros here, and then halfway, and then half of that is 1.5, and half of that, 4.5. All right, there is my horizontal compression of pi over 3. Notice, very close, because it's just a shade off. Just a shade off. Okay? All right, so let's take a look at this function. If I have the cosine of a half x, again, let me go ahead and graph my parent function. That way we can compare it here in the end. 0.57, 4.71. Another reason I draw the parent function is just because it gives me more practice. So this is my parent function of the cosine. So I'm going to take a look at the amplitude. The amplitude is going to be that a value in front of that cosine. Well, it's 1. Absolute value of that is 1. The period. Well, the period is 2 pi over absolute value of b. Well, that's going to be 2 pi over a half. Absolute value of a half. Well, that would be 2 pi divided by a half, which is the same as 2 pi times the reciprocal. Well, that is 4 pi. All right, well, let's see. What is 4 pi anyway? So if I take 3.14 and I multiply by 4, it's about 12.56. All right, so I need to add a little bit more here. Here's a 9, 10, 11, and a 12 right there. I need to expand this graph a little bit. Okay. All right, so here's what I know. When I'm graphing my new function, it has a period of 4 pi. That means it's going to go here from 0 to 12.56. So that might even be out here a little bit, right? So graphing that, let's see, amplitude's still 1, so my midline's at 0 because I haven't added or subtracted anything. Then here is my maximums. The minimum's going to be about half that. So half of 4 pi is 2 pi, so 6.28. And then between 0 and 2 pi, half of that is pi, so I'm going to have a 0 here at pi. And then between 2 pi and 4 pi, that gives me 3 pi. And 3 pi is about 9.42. So if I go 9.42, that will give me my other 0. Notice what happens. My graph, which my parent function had a period of 2 pi, is now stretched to 4 pi. Well, if it's stretched, that means this horizontal stretch of a half. Okay? So again, you're taking the parent function and stretching it to a period that's going to be larger than 2 pi. All right? And you're going to use your b value in order to find exactly what that period is. All right, let's take a look at this last one. Let me go ahead and graph my parent function. That way you can kind of take a look and see what that looks like. So I have my maximums, my minimums, I need my zeros. And I'm going to graph it. And there's my parent function. Okay, that parent function has a period of 2 pi. Looking at my new function, y equals cosine of 2 pi x. Let's see, amplitude. Let's see here. Amplitude, a value is 1, so absolute value of 1 is still 1. The period, well, let's see, what is b? b is 2 pi. So that means my period is 2 pi over absolute value of 2 pi. Well, that's 2 pi over 2 pi, and the period is 1. Okay? So the period is 1. Let me write that down, a little easier to see. That means between 0 and 1, I should see an entire cosine wave, entire cosine function. So I'm going to draw my maximums, halfway, my minimum, and between my maximum and my minimum, it's going to cross the x-axis. That is one period, one cycle of y equals cosine of 2 pi x. Again, if I wanted to draw another one, let's practice doing that. You got your maximums, your minimums, your zeros. So a lot of times you're just doing halves of halves. Okay? All right, let's see. What would this be? Well, if I went from a period of 2 pi, which is 6.28, and now my period is 1, that is a horizontal compression of 2 pi. All right, so that's how you're going to deal with your horizontal and stretches and shrinks, so stretches and compressions. It is going to give you a period change, and you always want to take care of that period change first.